Hi, hello, vanakkam, and welcome back to yet another episode on your favorite Little Slaw YouTube channel. So today in this video, we're going to see what is Prometheus, how to set up Prometheus, and we'll see how to integrate Prometheus with Grafana. So this is going to be the scope of this particular video. So in case if you're looking for how to integrate JMeter with Prometheus with Grafana, we'll have to wait for the next video. And in fact, going forward, we'll try to use, try to look into more Grafana related videos in the upcoming sessions. And if you're really interested to watch more videos on DevOps, performance testing, performance engineering, and please do comment your comments. Please do comment your comment and give me your feedbacks in the comment section. So let's first see what is Prometheus. So we're going to see how to install the Prometheus as well. And in this video, we'll see what is Prometheus. So Prometheus is it's an open source toolkit which is used for monitoring the systems and setting up alerts. And it was originally created by the team at SoundCloud back in 2012. And over the years, it's been widely adapted by many organizations due to its reliability and active community support. So in 2016, Prometheus joined the Cloud Native. That's what I mentioned here as CNCF. It has joined the Cloud Native Computing Foundations. That's a CNCF, which has become the second hosted project after Kubernetes. And this move emphasized its independence from any single company and clarified its community-driven governance structure. So we'll see how this Prometheus works as well, because like I told you, it's very powerful and it's an open source tool for monitoring the systems. And now we'll move on to the next part, which is how does the Prometheus work. And now we'll move on to the next part, which is how does Prometheus work. So at its core, Prometheus collects and stores the metrics as time series data. So this is again another tool which is like, it looks like the InfluxDB, because both of them collects the time series data. So this means it saves the information about the system's performance along with the exact timestamp it was recorded. And to make this data more useful, we can attach the key value pairs, which is known as the labels, to our metrics, or which allows for detailed filtering and analysis. And if you're looking for a deeper dive, we will we'll move on to this next part. So as I have told you, let's now see the features of the Prometheus tool. So the first of it is the multi-dimensional data model. So when I say multi-dimensional, so Prometheus uses a data model where time series are uniquely identified by 2 points, two components. So the first thing is the metric name, which describes the measurement, that is the CPU usage, the HTTP request total. And then the second of it is the key value pair, which is the one that we call it as labels, where we add the context to the metric. That is, we do have an example like a metric. So when we want to calculate the metric, the HTTP request total, we use the method get, and we collect whatever request it has a status of 200, and then we use the instance like the server name. So this flexibility, in terms of allowing for deeper insights, so using that we can track the metrics across multiple dimensions, such as requests by method or by server or by the response status. So we can use multi-dimensional. So that's the reason I'm telling you the Prometheus is multi-dimensional in terms of collecting the data. So you can use the method, so for in this example the get method, and then you can use the status, which is like the response code, which is 200, and you can also use the instance, which is the server name. So you can collect, or you can track the metrics across multiple dimensions. So that is the very first important feature of Prometheus. And the second one, which is the PromQL, which is the Prometheus query language, which is again a very flexible query language, because Prometheus provides the PromQL, which is a very powerful query language for analyzing and visualizing the metrics. So it's not just analyzing, it's also we can just visualize it, because Just before I have told you like what are all the metrics we have, like like what ways we can track the metrics in terms of the method, in terms of the status, and in terms of the instance. And by doing that, we need, so for doing all this, like we need to have a very good control, and for that we are using the PromQL, which is a powerful query language, and that is used for analyzing and visualizing the metrics. And this leverages the dimensionality of the data model. For example, let me give you a quick example. So we do have a query to calculate the average CPU across all servers. Yes, we can very well do that by using average rate of CPU usage for the last 5 minutes, and we can even query the HTTP filter request with 500 status code, like whatever response has 500 status code, we can even filter that by running HTTP requests total status equal to 500, because this PromQL, which is the Prometheus query language, makes it easy to extract actionable insights from complex data. And then the third part, which is the no reliance on distributed storage. So what does it mean, no reliance on distributed storage? Doesn't it look completely outside the scope? Yes. The point here is Prometheus servers are autonomous, which means they don't rely on distributed systems for storage, because each server stores its own data locally. So that's the reason I'm telling you that the Prometheus are, they don't rely on distributed storage. And this simplicity, which is storing the data in its own server, and because of that it improves the reliability and makes the deployment straightforward. And for example, let me give you a quick use case. So even in a setup with multiple Prometheus servers, each can operate independently. If one server fails, the other remain unaffected, and that is the reason I would say that having no reliance on distributed storage is the advantage of using the Prometheus. And then the fourth feature is the time series collection. So I would call it as pull based data collection, because Prometheus collects metrics using a pull model over HTTP, because it periodically scrapes the data from configured targets such as application endpoints or exporters. And for example, I have a web application which exposes its metrics at /metrics, and Prometheus scrapes, it does not extract, it actually scrapes this endpoint every 30 seconds to collect the updated data. And because of that, that's the only reason we were able to collect and analyze the data, even though it is multidimensional. And one of the advantages is Prometheus decouples the system. We normally do the decoupling of the system which are being monitored from Prometheus, and which avoids the need for constant data pushes. We don't need to worry about pushing, because like I told you, Prometheus will collect the metrics using the pull model, which will actually scrape the data for every 30 seconds. So you don't need to worry about pushing the data to the Prometheus. And then the next one, which is the push model supports. Previously we saw about the pull based data collection. Now I'll tell you about the push model supports. What is the meaning of push model support, which is that pushing time series? So what happens is, although Prometheus is pull based by default, which is what I was telling you about the scraping of data for every 30 seconds, it also supports pushing metrics through an intermediary gateway. So when I say through an intermediary gateway, it is useful for systems that cannot be scraped directly, such as short-lived jobs. So for example, a batch job which writes metrics to a push gateway, and Prometheus then scrapes the push gateway to retrieve the data. And that is the fifth feature. So even though, like I told you, Prometheus supports pulling the data, but it also supports the push model support, which is it supports the pushing of metrics through an intermediary gateway. And the next one, which is the dynamic target discovery, in one word. So which is Prometheus supports the service discovery to automatically find the monitoring targets, and in fact it integrates with platforms like Kubernetes, AWS, and Consul for dynamic environments. And when it comes to static configuration, it is also available for manually defined targets. So for an example, I would say that in a Kubernetes cluster, Prometheus can automatically discover new pods as they are deployed, and thanks to integration with Kubernetes APIs. And then the next feature, which is the graphing and dashboarding, and that's the last feature. So what is graphing and dashboarding? So Prometheus, as you all know, it supports multiple visualization tools. It has also built-in expression browser for quick metric exploration, and it integrates seamlessly with Grafana for rich customizable dashboards. For example, you can use PromQL queries to create a Grafana dashboard that visualizes the CPU and memory usage over time, and the HTTP requests rates grouped by endpoint and status code. For example, let me just give you the summary of benefits. I would say the Prometheus features actually makes it a versatile tool for monitoring modern dynamic systems, and in fact the multi-dimensional data model which ensures metrics are context rich, and the PromQL, the second point which I was telling you, the Prometheus QL, which enables advanced querying for actionable insights. So the combination of pull based, the one that I was telling about the time series collection, the pull based, and then we are having the push based. So these features, I mean, the combination of this pull based, the dynamic discovery and graphing supports provide a robust end-to-end monitoring solution, and because of these features it allows Prometheus to scale effectively across diverse use cases from small applications to large-scale distributed systems. So now actually we'll see about what are metrics and what are the components of Prometheus, the architecture of Prometheus, and when does it fit and when does it not fit. So in this video we'll see the next part, which is how to install the Prometheus using Docker, and we'll see how to connect or integrate the Prometheus with the Grafana. So as I have told you, I'll show you how to install the Prometheus in Docker, and for that let me I have opened my Docker desktop, and then I'll open the terminal here itself. So I'm just clicking on the terminal at the bottom, and let me navigate to the folder where I want to install the Docker, and it is cd and then cd space c drive /fs and then cd docker. Yeah, so I'm going to install it here. So this is the location where I'm going to install it. Let me just quickly check the button. So we don't have anything, so it's completely empty. And what I'm going to do is first let me create a folder for this. So for that, make dir and then the Prometheus. So this will create a folder for us, and then inside this part I'm going to let me just do a cd Prometheus, and then let me do a docker pull. So for that I'm going to docker pull and then prom/Prometheus. So this will get us the latest Prometheus in our machine, latest image that has to be built, and this step actually will download the official Prometheus Docker image from the Docker Hub. So that's what we are going to do. That's what we are doing. So we're just downloading the official Prometheus Docker image from the Docker Hub, and now we have downloaded successfully. And as you have seen, we have created a folder, and then the next part is we have to we are inside the Prometheus folder, and there are like no files. So the next part is we have to create a file which is prometheus.yaml YAML file, where we have to add the configuration. So let me just go inside the folder, and let me do right click new and then text document, and that's going to be Prometheus.yaml. So the same thing which you have to do as well. Yes, Prometheus.yaml, Prometheus.yaml, yes, and then right click, open with Notepad++, and then I'm going to add the following basic configuration. So let me just give it directly here. So it is the scrape interval. So as we already saw in the previous part, where we're going to pull the data, and that for that I'm going to use the scraping, and this part will do the scraping for every 15 seconds. And just imagine if you want to increase it to 30 seconds, yes, we can let you do that as well. And the job name is going to be Prometheus, and the target, the local host is 90. In case if you want to refer a different location, you can even refer that as well. In our case, this is the same thing. So the scrape interval is 15 seconds. So let me just change it to 30 seconds. And then let me just change it to 30 seconds. And then the job name is Prometheus, and the target is localhost 9090. Let me save this, and we are good now. And the next part is we're going to run the Prometheus in Docker. And let me go back to the Docker. So now if I come back to the images and let me do a quick refresh. And yep, here we can see the Prometheus, but it is not yet still started. So if you see in the container part, the last start, nothing has been started yet. So let's start the Prometheus thing. And for that, Docker run -d and then minus name, and it's going to be Prometheus -p 9090 colon. So that's the port number. And then we have the next part, which is -v, and it is inside C drive dfs docker prometheus.yaml :etc/prometheus. Why etc is, that's how the data structure of the Linux part works. Then again another prometheus.yaml, and then from.prometheus. Give me an enter. So this has actually started. So if you have seen here, it's changed to green, it's running. We have got the container that's running, the Prometheus, the images shows from Prometheus. The port number is 9090 and it's running now. So here you can see the container memory usage has been increased, and then we have got to see CPU percentage of 0%, and then we have, it shows that it started 13 seconds ago. Let me click on this link. So this is one way where we can do this, or else we can even directly type this part, that localhost :9090/query, and that will get us the Prometheus screen. And this is what we are going to see. And like I told you, we'll see the architecture, how does it work and everything in our next video, the metrics part and everything. And next thing is, let's connect it to the Grafana. For that, I'm going to open localhost 3000. Again, let's go back to the idea first data source. And the first thing, yes, the open source time series database and alerting. Clicking on it, Prometheus integration, and then coming back to this Prometheus URL, can copy it from here, the localhost 9090. Come back to this Prometheus, it's going to be HTTP localhost 9090, and I'm not going to add any cookies. There are no time. Let me add the timeout of just 60 seconds, which is like basically 1 minute. And then the authentication, yes, I'm going to use the very not the username and password, but it's just the very basic authentication. The TLS client authentication as well. I'm going to skip the TLS verification. I'm going to forward the O authorization identity. And in case if I want to add any header, I can click on this header and I can add the header part. But for now, I don't add any headers. And the scrape interval, yes, as you mentioned there, we can even mention it here as well. It's going to be 30 seconds. The query timeout is going to be 60 seconds. And the default editor is the builder. In case if you want to run it through code, you can even very well select that. But the default for me is going to be the builder. And the Prometheus type, let me just select this one. So we do have 4 types of Prometheus. One is Prometheus types. One is the Prometheus, the other one is Cortex, Mimir, and Thanos. So you must have heard that in movies, but yeah, that's how this works. So I'm going to just leave it as default, and the cache load is going to be low. And why is it? Because when we are setting this browser caching level for the editor queries, so the higher cache settings are recommended for high cardinality data sources, and this is going to be a very basic testing. So for that reason, I'm going to use low, and rest everything is fine. So let me click on save and test. Yes, successfully queried the Prometheus API, so which means I can access the Prometheus database. And if I go to explore data, and here you can very well see I have connected successfully to the Prometheus connection, and I can even see the labels, the metrics, and everything. So in our next video, we will see how to effectively use it. We'll see what are the other topics in terms of the Prometheus, and even we'll see how to use or how to connect with the other performance testing tools. So until then, it's me, Yosin Shanmugam. I'm taking a break. Bye bye from me, and see you all in the next video. Until then, it's bye bye from Yosin Shanmugam and your favorite Little Star YouTube channel. Take care and bye bye.